This is passage 2. It's the conflicts passage. So in our DRC approach, C stands for conflicts, and carefully read. It is the only conflicts passage in a test. There's only one in each test, and you want to identify the conflicts, then annotate the differences. You're going to probably spend more time with the passage and less time with the questions than on some of the other types of passages. Our approach to the questions is still read and reread. We're also going to take time and break down this passage. Your first step is to identify the conflict. It's usually the last sentence of the first paragraph. So here's our first paragraph, a little bit bigger. We have amino acids are molecules necessary for life. We have amino acids are chemical reactions amongst ammonia, methane, hydrogen, and water. And then here's the conflict. 4 hypotheses have been proposed to describe the conditions that were responsible for the production of amino acids on Earth. So just how did we get amino acids on Earth? Your next step is to break down each hypothesis. I like to draw pictures with these. It helps me to remember. So for this one, amino acids were introduced to Earth by meteors. So I'm going to put meteors. That's my meteor pictures. They don't have to be perfect. Don't have to be pretty. And containing all the elements. The reactions amongst the 4 substances provided enough energy for amino acids to be produced. When they entered, they were rapidly heated by frictions. I just put some kind of flames to say heated, and this resulted in immediate amino acid production on the surface of the meteors. So I just wrote amino acids on the meteors. This is what it looked like when I drew it on the test. It was quick. There's my meteors, my little flames, and check marks to say that's where the amino acids were. Hypothesis 2 says hypothesis 1 is correct that meteors brought the elements. It does, however, say they were released into the atmosphere. So I drew a little cloud with the amino acids on the atmosphere. It says the UV light provided the energy. So I drew a little UV sunlight. And there's my picture that I drew. So I have my meteors released into the atmosphere and UV light. Hypothesis 3 is different. So meteors have nothing to do with it. Instead, it's thermal vent cracks in the floors of the oceans. I have my ocean, I have my thermal vent cracks. Allowed magma to seep into the oceans. There's my magma. Caused the water to boil. Drew some bubbles for boiling. And then it's dissolved into the atmosphere. So there's my cloud with my amino acids in it again. And the UV light provided energy. So there's my sun. There's my picture from when I drew it. So I have my vent, my flames, my bubbles. There's the ocean, clouds, UV light. That will help me remember which hypothesis does what. It's easier than trying to look back at all the words. Hypothesis 4, we have thermal vents again, but it says that it didn't cause the water to boil. Instead, it just reacts with the ocean water to create amino acids, and they occur near thermal vents. There's my picture. It's a little more convoluted. Ocean. That's the ocean water reacting. So now we have all 4 of our hypotheses. 1, 2, 3, 4, and we can go to the questions. Number 8. Suppose a scientist determined that UV light does not provide enough energy. This would weaken which hypotheses? So we know that UV light is needed in hypotheses 2 and 3. So that would weaken hypothesis 2 and 3 if UV light doesn't provide enough energy. So H. Number 9. Hypothesis 3 and 4 agree on which aspect of amino acid production. So let's just break them down. The source of the substance is needed. Well, they both need the cracks in the ocean floor and the magma. So yes, 1 is correct. 2, the location of amino acid production. In hypothesis 3, it's in the atmosphere, and 4, it's in the water, so that one is not correct. Let's check out number 3, the source of energy needed. In hypothesis 3, it's UV light, and 4, it's water. So it has to be choice A, which we could have gotten right after the second one, right? So once we know it was 1, it's either A or D, and once we eliminated 2, we know it has to be A. Number 10, which hypothesis, 1 and 2, if either states that amino acid production occurred on the surface of the meteor. So the one that's on the surface is hypothesis 1, so F. Which hypothesis suggests the reactions occur in an aqueous solution, so water or liquid? So that's going to be hypothesis 4, in the ocean, so D. Number 12, the chemical formula for glycine is that, based on the information in the passage, we're probably going to use the text that was the introduction. How many molecules of methane would be needed to provide the correct number of carbon atoms? Actually, you can use any part of this as long as you know methane is CH4, so it has 1 carbon. You need 2 carbons for glycine, so you will need 2 methanes, so G. Number 13, look how lovely this is. The diagram below best illustrates which hypothesis. Hypothesis 3, and I think we did a pretty good job of representing that. Look, we got the thermal vents, the magma, thermal vent magma. We've got our water boiling, they didn't do the boiling. We did a better job there. The ocean into the atmosphere and the sunlight. So we got pretty close to the same design. So your answer is C. Number 14, which hypothesis claims that amino acid production occurred within the thermal vents? We know it's not 1 and 2. That's because 1 is on meteors, 2 is in the atmosphere, 3 is also in the atmosphere, and 4 is in the ocean water. So actually none of them. 3 and 4 have thermal vents, but that's not where the amino acid production occurred. So your answer has to be J. All right, reach out if you have any questions. And for our silly joke, do you know how long dinosaurs live? Probably in about the same way as the short ones do. Have a good day.